What comes to mind when you hear the term VPN? For me, I think drop connections, constant logins, and frustratingly slow downloads. And as companies shift from a predominantly office workplace to a hybrid or a completely remote one, fast, secure, and reliable access to your resources is a critical requirement. Now, if you work with AWS, as I'm sure most of you do, gaining access to private resources like a database or an EC2 instance can be a real frustrating experience. On one hand, we want things to be easy for developers, but we also don't want to compromise on things like security or reliability. Take an RDS database, for example, that's hosting production workloads. Any good company will know that this database needs to be placed in a private subnet, meaning that it's hidden from the eyes of the public internet. That's just good security. This also means that it's hidden from you as well, a savvy developer trying to get into your production data. Most folks get around this problem through a handful of ways. This can consist of a jump box that sits in a public subnet and facilitates connections with your database. This can be tricky to set up while also having some scalability concerns and be a single point of failure. Another option is to use AWS's dedicated VPN service, which can be more reliable, but also introduces new challenges, including a hefty price tag and complex configuration, to name a few. What many of us are looking for is a fast, reliable, cheap, and most importantly, an easy to set up and use networking solution that enables us to securely access our AWS resources. This is where Twingate comes in. Twingate is a VPN alternative that allows you to easily gain access to your cloud infrastructure without compromising on security or ease of use. It's super simple to set up and features some incredibly powerful features like least privilege access, device security requirements, and audit trails, to name a few. In less than 10 minutes, I was able to complete the end-to-end setup with my AWS account. I deployed the Twingate AMI into my VPC, registered my RDS database via the Twingate website, and boom, I was able to access my database right from my home machine without having to do any more work. No more IP-based whitelisting, JumpBox setup, or painful configuration every time I need access. Twingate makes it super easy to get started for individual users, small teams, or even large organizations. You can easily import your existing user base from identity providers like Okta or Google Workspaces. And you can define custom groups to specify who has access to what. You can also enforce certain security requirements on user machines, like antivirus or biometric configuration. And if they don't have it enabled, then they can't connect. And on top of all of that, Twingate is free to use for up to 5 users. And that's more than enough for my use case. So let's get this set up on our AWS account right now. It's super straightforward to do and takes less than 10 minutes. So here's the game plan. Here we have our AWS account, and within it is our RDS Postgres instance that's placed in a private subnet. This means that it has no public IP address and cannot make outbound or receive inbound calls from the public internet. Our goal is to make it so that we can access the database from our home network using pgadmin, and to do that, we'll be using Twingate. Now, Twingate has 4 moving parts that make it work: the client, the controller, the connector, and the relay. Let's briefly run through the ones that you need to know about, for now at least. Let's start with the connector. The connector is a piece of infrastructure that we deploy inside of our AWS account, behind our VPC firewall. Connectors are responsible for facilitating the connection between our RDS instance and our home client. Next, we have our controller. The controller is a component that exists inside of Twingate and acts as a hub for centralized coordination. We interact with the controller via the Twingate console to do things like add our resources, grant permissions, and other configuration tasks. The controller also allows Twingate to discover our connector that's deployed inside of our AWS account. Next, we have the client. The client is pretty simple. It's just a small piece of software that we install on our device. It helps us authenticate with Twingate and makes requests to our protected resources. Now we do also have a fourth component called the relay, which is quite important, but we're going to come back to that a little bit later. For now, that's all we need to know about Twingate to get started with our demo. Now to make things easy, we're going to approach this in a 5-step process. First, we'll head over to the Twingate console to create an account and initialize our controller. Second, we'll go to our AWS account and deploy a connector onto an EC2 instance. Third, we'll register our RDS database as a resource in the Twingate console. This will make it visible to Twingate and allow clients to connect to it. Fourth, we'll download and install the Twingate client onto our home machine. And finally, we'll boot up pgadmin and connect to our RDS instance. So let's head over into the console and get started. Alrighty, so here we are on the Twingate website, which is twingate.com. And to get started, we're just going to click on this yellow button here to try Twingate for free. This is going to launch the registration wizard. And so as you can see at the top here, there's a 14-day trial of Twingate Business that's included, no credit card details, yada, 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 and Twingate Starter is free forever. So no payment details are required here, and you can use this as long as you want if you use the starter version. So we are going to use Google here, so I'm just going to click on sign up with Google, and I'm just going to select my email here. And so now it's prompting us to enter a company. You can put in whatever company that you want here. The name doesn't really matter. So let's just call this Be a Better Dev, Dev Co. Okay, and number of employees, I have less than 100, absolutely, and we're going to click on finish signing up here. So how do you plan to use Twingate? Definitely secure access to our private network, IP whitelisting, maybe this, not sure, personal projects, and improve my security posture. That sounds good as well. So let's go ahead and click on next here now. And are you able to deploy Twingate on your own? Yes, of course. I'm able to run some CLI commands, and we're going to go ahead and click on next as well. And so this is the name of our new network. So it's Be a Better Dev Co. You're going to need to remember this because when we sign into our client later, we're going to need to provide the network URL. So it's just beabetterDevCo.twingate.com. So let's go ahead now and click on create network here and building your network. We're going to be redirected in a moment here. All right, so this is the Twingate admin console or the admin panel. And as you can see here, there's a couple things that it's telling us to do as part of our setup guide. So the first step is to define our network. So this involves adding a remote network and at least one resource that you like to access, then to set up a connection, then to install the Twingate client. These are similar to the steps that we ran through a little bit earlier. So we've successfully created our account here. So what we need to do now is over on the right-hand side, go to add a remote network. And here is where we're going to add some details for our AWS account so that we can tell Twingate what to connect to and generate some commands so we can launch our EC2 instance. So I'm going to click on add a remote network here. For location, it's AWS. We can call this whatever we want. So let's call this AWS-prod, for example. Go ahead and click on add remote network here. All right, so at this point, what we need to do is deploy a connector into our AWS accounts. And as you can see on the left-hand side here, Twingate has provided us with two different connectors. And the reason that there's two is to achieve higher levels of availability in the case that one of your connectors unfortunately goes down. Now for production use cases, what Twingate suggests is to use two or more and also deploy them into separate availability zones. And so what that means for you as a user is that if an availability zone does go down in the AWS ecosystem, you'll still be able to access your resources in your AWS accounts through your other connector. And if you want, you can click on this add connector button here to add a couple more, and you can click this as many times as you want. But for our use case, at least in a demo, we just want to use one connector here. So let's select Meteoric, Leopard. These are all randomly named. I'm just choosing the one that I like best here. So we're going to click on this guy. And so what we need to do now is to select a deployment method. Now you have multiple different options that you can use here. So there's a Docker container, there's Helm, there's ECS. Obviously we don't want to use Azure, but in our case, we want to use an AWS AMI that we are going to be deploying onto an EC2 instance. Now for those of you that are AWS users, you're probably going to use either this option here or AWS ECS. And which one is right for you just depends on what you're familiar with. So for me, I'm most familiar with EC2s because I work with them a lot. So I'm just going to select AWS AMI here. And so the next step for us is to generate some tokens. And so we're going to click on this generate tokens button. So that's going to ask us to re-authenticate, which is totally fine. Going to sign in again, and it may ask me for my password here in a second, which I will provide. It did not, it was saved, thankfully. Let's get rid of that. And scrolling down here, we do need to provide some additional details for our AWS AMI command. And what we're doing here is filling out these details, and Twingate is going to generate a CLI command that we're going to run in the AWS console, and that's going to bring up our EC2 instance with the correct AMI, so that's basically ready to go, and it's going to be detected by Twingate once we do that. So what we want to do here is we want to select the region. So we're in US East 1 here, or North Virginia. So for subnet ID, we can easily go ahead and grab that. Let me show you how to do that really quick. I just have another tab open with my AWS account, and I want to go to the VPC section, which I have another tab here. And this is the default AWS VPC. If you take a look at the resource map, which is a pretty neat new AWS feature, you can see the different subnets that you have in your account. Now, by default, you'll have a subnet in each AWS availability zone. And so I'm just going to select this one here since I know that it is indeed a public subnet. So we're just going to take this and copy this to our clipboard. Then we're going to go back to Twingate. We're going to paste that sucker in there. Okay, we're ready to go. You can also provide your security group ID, your SSH key name, your DNS server. Not all this is optional. You don't necessarily need to provide it, but you can if you wish. Okay, so step 4 here, which is to run a command that's going to bring up our EC2 instance. And all of the details have been substituted into this command. And it's basically just going to create our instance for us. So what we want to do is just grab this. I believe they also have a copy command. Yeah, there it is, copy command. So we copied that to our clipboard. So now we can go back to our AWS account and just run this command in the terminal. Now you can do this from your home machine if you wish, if you have the AWS CLI installed. But I'm going to use Cloud Shell, which allows us to do that directly here from the AWS console. And if you want to access it by yourself, you can go ahead and click on this button up here. This will launch a new instance for us. It does take some time to initialize, but I already did that previously. And here is what the terminal looks like. So let's just clear this out. Now we're going to paste this command in. All right, so that was pasted in. We press enter now. And we should see a confirmation message here. So yes, we do. Now, one thing to keep in mind is that the instance type that's provided as part of this command is a T3A micro, which does cost money. It's a nominal amount per month, but it's not zero. So if you want this to be free, you can use a T2 micro instance, which is free. It's part of the AWS free tier. So this instance is currently pending according to this command. So let's actually close Cloud Shell out. We don't need this anymore, and go back to our EC2 section of the console. And we're going to go ahead and refresh this now. Yeah, so we do see our instance here, and this was the Meteoric Leopard that we just saw, and it's currently in running state. It's doing just a status check right now, but this should be good enough for Twingate to detect this instance at this point in time. And so what's happening here is that behind the scenes, when you bring up this instance, this machine is communicating with the Twingate controller to kind of register itself so that Twingate has knowledge of it in your AWS account. So if we go back to our other tab here for Twingate, and we obviously it's still on wait for connection here, but if we go back, we don't need to look at this anymore. Back to networks. You can see we have set up connection to your network, which has been completed. If we go back to our remote network, which is our AWS prod, you can see now there's this green dot here beside Meteoric Leopard. And so I believe if you click on this, you can see more details. Yes. So we have our controller that's been successfully connected, and we also have our relay. Now we haven't really talked about the relay. We're not going to do that now, but that's something that we're going to discuss in the how it works section of this video. Okay, so now what we want to do is add our RDS database as a resource in Twingate. This is going to make our database visible to Twingate so that we can actually connect to it from our home machine at a later step. So any resource that you want to provide access to via the Twingate tool, you're going to need to do a one-time configuration to add it as a resource here in Twingate. And then you could do some really cool stuff like add user-based permissions or group-based permissions so that only certain users can actually connect to your RDS database. So let's go back to AWS prod here, and we are going to click on create resource under our remote network. So we're going to click on this. And so this is going to now ask us some details of our RDS instance. And so in order to get this information, I'm going to go back into our AWS console here, and we're going to just take a look at our database instance really quick and grab the address information. So switching tabs here, and I have one open for RDS, so let's click on that as well. And so here's the RDS instance that we want to add as a resource in Twingate. So I want to show you some details about this instance before we add it as a resource. So when I created this instance, one of the settings that I specified is not enabling public accessibility. So no for public accessibility. What that means is that this instance does not have a public IP address. And since it does not have a public IP address, nothing from the public internet can see this instance. It's basically hidden from the eyes of the internet. And that's great for us. We don't want anyone knowing about this instance except for us. But because we deployed our connector inside of our AWS account, we can actually use this private DNS entry here, which is just the endpoint, and Twingate will have visibility into this instance. So what I'm going to do is I'm going to grab this endpoint here. We're just going to go to copy, and we're going to go back to Twingate. And we can label this whatever we want. Let's just call this RDS-1. And for address, we're going to paste in this address here and just put that in. You can also do some port restrictions as well. So we're going to allow port 5432, which is default Postgres port. And you can also do stuff with UDP if you want to just block UDP in total. Actually, we'll do that. We'll block UDP. We're also going to block ICMP as well. So this basically only has access to TCP on port 5432. So that looks good. We're going to go ahead and click on Create Resource now. And now this is a pretty neat section as well. Assuming you had different users and potentially different groups in your account, you're able to add specific groups or users that have access to this instance. And this is the really, really cool part of using Twingate. You get user-based access controls that are built in out of the box, so you don't have to worry about this stuff or build some kind of custom solution to make this work. So since we only have one user, which is in this case me, I'm just going to click on everyone here, and we're going to say add one group. And you can see now right away, you see the green check mark here. And so this resource, this RDS instance, has now been detected by Twingate. And if we click on this, we'll be able to see more details. And the cool part, I talked about audit trails a little bit earlier as well. You'll be able to see audit trails for when users try to connect to this RDS instance using Postgres or Datagrip or whatever you prefer to use. And this is great from a governance and accountability or audit trail perspective. If you need to know who and what is accessing your instance's data at any point, all of it is going to be enumerated and listed here so that you can check that information out later and audit it if you need to. All right, so we've completed the register resource step. Like everything is good to go in this account. Just to summarize, if we go back to network here, so we just have to install the Twingate client. But you can see we have a remote network, and within a remote network is our resource. And you can add more resources, but like we saw, we just have this RDS resource now. And so what we want to do is proceed with the fourth step, which is to download and install the Twingate client. So let's go and do that now. All right, so here we are on the twingate.com/download website. And this is just a one-time thing that you need to do. You need to download and install the Twingate client here. So you can download it for Windows. It auto-detected that I'm on Windows, so it's going to give us the Windows installation. You can also get the MSI as well. Also supported for other platforms. So if you have a Mac, you can download the Mac version, Linux, Chrome, iOS, whatever your operating system is, you can go ahead and download the installer here. So I'm not going to bore you with the details. It's a fairly trivial thing. You just click on next, 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 and you're good to go. We're going to assume that you were able to get this puppy installed, and I'm going to show you how to link your client to your network that we just created via the Twingate admin console. So I have it open here on the side. This is going to be the default that you see here. So connect to a network. And so what it's asking us to do is to enter the name of our network. So remember in the beginning of the video, I asked you to remember what the name of our network was. Pop quiz time. What was the name of our network? I believe it was beabetterdevco.com or beabetterdevco. I really hope this is right. It's going to be embarrassing. Click on join network. Okay, please be right or I'm going to be really upset. Okay, this just opened a new tab that it's asking for us to authenticate. So I'm going to go ahead and open that for you here. So we're going to click on sign in with Google again. It's going to auto recognize our account. Hopefully there it is. and we should be good to go here. So we're automatically authenticating, and now we are connected via the Twingate client. So that's all you really need to do for connecting to Twingate, and you can set it up. There's a setting for the Twingate client where you can automatically launch this when your machine starts up, so you don't have to worry about this at any time, and basically you're always going to be directly connected to your network without having to do any work at all. So at this point, we're pretty much good to go to try and connect to our RDS instance from my home machine now and just see if everything works. So let's go ahead and grab the DNS entry for RDS instance again. It was over here and it's our database details. And let me just recopy this, copy that. And I have pgadmin open in a separate tab. So we're going to use that to test our connection. And so let's go to servers here. We're going to register our server. We're going to click on server, add a name, so RDS1 or whatever you want this to be. And for connection, we're going to go ahead and add our host name or address. Keep in mind, this is the private DNS. It's not the public IP address. There is no public IP address for this. So this is another cool part. Like all of this is just happening behind the scenes outside of the public internet. It's a really neat security feature. And for password, if you enabled it, I did for my instance, so I'm just going to put that in here. We're going to go ahead and click on save, and hopefully this all worked. It looks to have been connected successfully. Okay, so let's check out what we got here inside of this database. So we have our RDS1, we have our databases here. I have a prod database, which I created in advance. And let's just go ahead and right click on it and go to query and check out the data that's inside of our table. I went ahead and created a students table. So let's see if we can access it here. So select star from students, and hopefully this will have some data in it that you can take a look at. So there you go. There is the data. So a bunch of different students were able to connect to our RDS instance from our home machine now without having the RDS instance to be publicly visible. All of this is happening behind the scenes through the Twingate network. Pretty awesome. So hopefully you can appreciate the power of Twingate here, but at this point, it's kind of important to understand how Twingate works behind the scenes. So what I want to do now is bring you back to the Blackboard and just explain to you kind of what's going on and what makes this whole machine tick and how it works end to end. So let's go ahead and do that now. So when we ran through the demo, we interacted with three moving parts: the client, the connector, and the controller. Now these are the main components that make Twingate work. So let's briefly recap the roles of each of these pieces, plus we'll discuss the missing link, the relay piece as well. So the client is the piece of software that we installed on our home machine. It's responsible for things like user authentication and routing traffic that's destined for your protected resources in your AWS account. The connector is a component that is deployed within our account and in a public subnet that has internet access. Note that the connector can also be placed in a private subnet for better security posture, but this approach will require a NAT gateway, which will incur extra cost. The role of the connector is to authenticate any incoming requests coming from the whitelisted client to ensure the requests are valid. Its other primary job is to forward those requests to destination resources, like our RDS instance in this example. The controller is the central coordination component of Twingate. It's the thing that makes this whole machine tick. It's responsible for things like authorization delegation, registering deployed connectors so Twingate has knowledge of them, generating access control lists, and storing the configuration of our entire setup. Now there's also another component that we haven't really discussed yet called the relay. The relay, like the controller, is also hosted inside of the Twingate network. Although we don't directly interact with the relay, it plays an important role in this whole song and dance. Its main responsibility is to act as a connection broker that matches incoming requests to the corresponding connector using a certificate-pinned TLS tunnel. So that's a bird's eye view of the different components and their roles. Let's now unwind the actual process that Twingate runs through during the initial setup and when trying to access resources from your home machine. Now, before traffic can be encrypted and start flowing from your home machine to your RDS, we need a way for your client and connector to discover each other and form a connection. This critical step is done via the relay. When a new connector is set up and deployed by you, it first authenticates itself with a controller by providing the authentication tokens. You'll remember that these tokens were generated by Twingate and provided to the connector when we initially ran the CLI command to boot up our EC2 instance. After validating each other's tokens, the connector forms a persistent connection with the relay. The client does something very similar. It first requires you to authenticate yourself using your user ID and password that you used when you registered your account. Post-authentication, the client also forms a connection with the relay. Now that the client and the connector both have a connection to the relay marries them together, allowing a direct connection between them using a secured TLS tunnel. Now, any requests from our client to our RDS instance will be proxied through our connector before finally hitting the database. This allows us to keep our RDS instance protected from the outside world while only needing to expose our connector to the public internet. Now, keep in mind this is a very, very simplified view for how Twingate works. It does a lot more in terms of security, but if you want to understand more about their architecture, you can check out their excellent documentation. I'll put a link down below in the description section of the video. So that's Twingate. If you want to give it a try, I'll leave a link to the Twingate website in the description section. And if you don't like Twingate, let me know why down in the comments section below. So thanks so much for watching, and I'll see you next time.